Hello everyone. We are going to discuss about thermoelectric transducer, particularly thermistor. Generally, transducer converts one form of energy into another form of energy. Here, thermoelectric transducers converts the temperature level into another form, that may be in resistor form or some other electrical voltage reference form. So we are going to discuss about thermistor. It is a thermal resistor, or we can say thermally controlled resistor. The resistance is depends upon the temperature. Input is temperature, output we are getting in terms of resistance. It may be used in where we need to measure the temperatures, the motor windings, or in car bannets. Suppose in the motor winding, if current increases inside the winding, it temperature increases. Temperature increases. Sometimes it shorts the winding. It maybe it cause damage the windings also. To avoid that, they are fixing thermistor along with the motor winding. Through that, we can find the temperature level. Accordingly, we can control the flow of current inside the motor winding. Similarly, in car also we can get the temperature level in the display through thermistor. Actually, thermistor is defined as a type of resistor whose electrical resistance varies with changes in temperature. Although all resistor resistance will fluctuate slightly with the temperature, a thermistor is particularly sensitive to temperature changes. As shown in screen, the symbol of resistor is look like this. The thermistor acts as a passive component in a circuit. There are an accurate, cheap, and robust way to measure temperature. While the thermistors do not work well in extremely hot or cold temperature, they are the sensor's choice for many different applications. So, the thermistor is ideal when a precise temperature reading is required. Different types of thermistors available depends upon the application we can choose. So here thermistor made up of oxides of metals such as nickel, manganese, cobalt, copper, uranium, etc. It is available in variety of shapes and sizes, commonly used for configurations or uh, disc type, bead type, rod type, etc. As shown in the screen, the disk type thermistor and rod type thermistor is used when greater power dissipation is required, and the rod type thermistor has high power handling capacity. The smallest thermistor in this configuration is the B type thermistor. Its diameter low as around 0.15 mm. The measurement element is typically encapsulated in a glass probe. It is commonly used for measurement of temperature in liquids. The screen shows the original structures of a thermistor. Depends upon application, we can choose that. Actually, the working principle of thermistor, it works on the simple principle of design and resistance due to the change in temperature. When ambient temperature changes, the thermistor starts self-heating its element. Its resistance value changed with respect to this change in temperature. So there are two types of thermistor. One is a PTC, another one is NTC. The NTC, as name suggests, negative temperature coefficient thermistor. There are ceramic semiconductors that have a high negative temperature coefficient of resistance. The resistance of NTC will decrease with increase in temperature in a non-linear manner. See, as on the screen, when temperature increases, the resistance decreases. In the PTC, there is a positive temperature coefficient resistor and are made up of polycrystal semi-ceramic materials. The resistance of PTC will increase with the increase in temperature in a non-linear manner. So the PTC thermistor shows only a small change of resistance with the temperature until switching point is reached. See on the screen, when temperature increases, the resistance value increases non-linearly. There are some limitations are there. The resistance versus temperature characteristics is highly non-linear. It's not a linear, not suitable for a wide temperature range because of high resistance thermistor. Shielded cables have to be used to minimize the electromagnetic interferences. The advantage is less expensive, more sensitive than other sensors, fast response, small in size. Disadvantage, as we discussed, limited temperature range and nonlinear ratio. An inaccurate measure may be obtained due to the self-heating effect and fragile. Application of thermistor. Digital thermostars, that means thermostats, automatic applications, that is to measure oil and coolant temperature in cars and trucks, household applications like a microwave, fridge, ovens, circuit production like surge production, rechargeable batteries to ensure correct battery temperature is maintained and to measure the thermal conductivity of electrical materials, useful in many basic electronic circuits, that is as a part of beginner Arduino starter kit, and temperature compensation to maintain the resistance to compensate for effects caused by the changes in temperature in another part of the circuits and used in Wheatstone bridge circuits also. Okay, so these are the some ideas about thermistor structure, construction, and working principle, and some application. Thank you.